Good morning. Are you all happy to be here this morning? Yes. Nice. Nice and chipper. I'm very happy to be here this morning, too. I submitted this talk, it feels like a really long time ago, through the normal RubyConf call for papers. And after I submitted it, I kind of thought, yeah, they're not going to take that. Mostly because the abstract that I wrote for the conference proposal was essentially just a rant. But what I had forgotten was that nobody likes a rant better than Rubyists do, with the possible exception of the political parties this close to the election. But don't worry, because after Tuesday, we'll be back on top. So I was still surprised, though, after they accepted the talk a few weeks later when Evan Phoenix asked me if he could make this talk a plenary session. I did have to look up what plenary session meant. But I was super excited that he asked because I love RubyConf. This is my 4th RubyConf. And every time I come, I have a marvelous time. I meet awesome people. I learn all the things, and it's awesome. So I love you guys. Thank you for having me. And I'm thrilled. I am thrilled that I tricked Evan into giving me this hour to rant in front of you. And I did trick him because despite the abstract, this talk contains absolutely no ranting whatsoever. Sorry. What I do want to talk about today is the set of factors that affect whether or not we write good code. So no one writes good code all the time. Present company accepted, of course. And the factors that go into whether or not the code we write is good at any particular time, there's a lot of them, and they're complicated. Now, I like to write good code. And I could say that it makes me happy to deliver business value, or that it makes me happy to create a product, and those are kind of true. But in reality, I like to write good code just because it makes me happy. And this picture makes me happy too, because clearly, the middle developer in that picture has just gone into the code she wrote 2 months ago and finished a very satisfying refactoring. So for me, code makes me happy when I can understand it 2 months after I wrote it. It makes me happy when it's easy to read, easy to use, easy to modify. But I don't always feel like that. And I want to feel like that more. I want to write good code more of the time. So that's what this talk is about. I was thinking perhaps I should have retitled it, Write More Good Code. And actually, maybe I should have, because that sounds more like a rant, doesn't it? So anyway, that's what we're going to talk about. Now, I started off researching for this talk by looking into how other people define good code. Personally, I like my definition. But it is subjective. It's qualitative. So I wanted to see if there was a quantitative way for us to evaluate the quality of code. And helpfully, academia has been working hard for like 40 years to get a more quantified definition of good code. And it turns out that good code is computable. In other words, it's possible for a computer to take 2 pieces of code and grade them against each other and say which one most developers will think is better. And it's a super complex computation, but the one thing out of it that's useful for us is that good code is defined by its pattern of dependencies. So let's look briefly at what a dependency is and how we incur them. Here's some code that I think I've written about 1 million times. This is a Rails controller with a show action. And on line 3, we are incurring 2 dependencies. First, we depend on the existence of the stuff model. And second, we depend on the stuff model having an instance method called find. Now, dependencies are important because dependencies in a project dictate whether or not the code is easy to change. So let me explain a little bit more what that means. Here's a conceptual diagram of a thing that other things depend on. So A, B, C, and X, Y, Z all depend on thing. They call some method in it, perhaps. So this code, we call this code is tightly coupled to thing, because if it changes, then potentially all the modules that depend on it would have to change. And then all the modules that depend on those might have to change. And it ripples out through the code base, and that's how we end up with a code base where changing something breaks something far away that seems unrelated. So I should point out, though, that not all dependencies are equal. This is a piece of the Pont du Gard aqueduct in France. It was built by the Romans about 2,000 years ago, which is pretty amazing. And there's many amazing things about this bridge, but one of them is that it was built mostly without mortar. So the stones in those arches are not cemented together. It's their weight and the physics of the arch structure that keep them in place. So this bridge has incurred a dependency on gravity. So if the way gravity works changes, then this bridge will need some refactoring. But given how often gravity changes, the Romans probably made the right decision when they tightly coupled their bridge to the force of gravity. So coming back to our software example, depending on things that don't change very often, such as your framework, at least one would hope, is safer than depending on things that change more often, right? So this is only going to cause you pain. Don't do that. So the key to keep in mind here is that good code is defined by its pattern of dependencies. And that seems to work whether it's a human evaluating the code or a computer. So since we have a definition for good code, though I personally still like mine better, let's back up and take a look at the factors that affect whether or not a particular person will write good code. So one important factor, for sure, is their knowledge of object-oriented design principles. Now, there have been several actually really great talks at RubyConf so far about object design. And knowing about object-oriented design means both knowing the principles themselves, right, such as solid and law of Demeter and all that stuff, and it also means knowing when it is appropriate to use them. And certainly people do write good code without knowing all the principles. But in general, if you want to write good code in an object-oriented language like Ruby, these things are quite useful and worth studying, because at their core, all of the object-oriented design principles are advice on how to manage your dependencies so that you end up with good code. Let's look at the law of Demeter for a moment so you can see what I mean. So the law of Demeter says in its very brief form that if you have an object, it's fine to call methods directly on it, but if you start chaining methods, you should think about whether there's a way to get the information you need more directly. And the reason is that the second line incurs a single dependency, but the third line incurs a whole chain of them. And if any of those things break, including all of the intermediate ones that we don't care about, then this code might also break. So the law of Demeter helps you avoid the far-reaching dependencies that characterize bad code. And if you analyze other object-oriented design principles, you'll find they're pretty much all little patterns that help you incur the right kind of dependencies in your code. So if all of this talk of design principles is a little too abstract, or if you just want to brush up, there's actually a fantastic book that came out recently. Sandy Metz's book, Practical Object-Oriented Design in Ruby. Anyone read that? Yes. The rest of you should read it. This book is amazing. It helped me see object design differently, and it is super concrete and practical, so I highly recommend it. So knowledge of object-oriented design is one factor that affects whether or not we write good code. Another big factor is the development practices that we follow. And over the last 15 or 20 years, we as an industry have decided that we write better code when we use the agile development practices. Now that's small a agile, right? Not any particular flavor, but in general, focusing on the user of the system and keeping your feedback loops as tight as possible. So test-driven development falls into this category, as does pair programming, fine-grained user stories, and all that stuff. So you need to pick the ones that work for you. Now these two factors are pretty obvious, right? If you're thinking about what affects how people write good code, these are obvious, they're easy to identify, and they're the ones that we focus on when we're thinking about how we can improve the quality of our code. Because there's always another screencast about object design, There's always another blog post about Agile. But there's a third factor that affects the quality of our code, and we typically don't think about it in this context that much. But overall, it actually has the biggest impact on the quality of our code, and that factor is, of course, other people. Okay, because to build anything interesting, you do usually have to work on a team. And in a team of this size, 7 people, which is more or less average, a single person in this team will personally write less than half of the code on the project, and probably significantly less than half. So most of the code you encounter every day will have been written by somebody else. So in some sense, if you want to work with good code and write good code, you and your team sink or swim together. Now, the team itself is more than just the individuals that compose it. It's also the communication patterns that exist between those people. Now, that's an interesting thing, because while you can't affect the other individuals very much, one person can have a huge impact on how communication works within a group. And it's been my gut instinct for a while now that it's the communication patterns in the group rather than the individuals within it that determine whether or not they produce good code together. So I set out to see if science could help me confirm or deny. So one thing that's hard about this is that formal lines of communication, such as like between a manager and their report, are really easy to see and really easy to visualize. But informal communication, which science tells us is more powerful in the workplace, is really hard to see. And we don't notice it. I like this quote that Jim put up yesterday, so I'm going to put it up again. The aspects of things that are most important to us are hidden because of their simplicity and familiarity. So informal lines of communication between people on your team are sort of ad hoc, and they're fluid, and they're constantly changing. And that's partially why we don't see them. They're just so normal. And to distinguish between informal communication and formal communication, informal includes things like chatting on campfire, or meeting in the kitchen, or going out to lunch, or having drinks. But the interesting thing about that is that when you're having a conversation with someone at work, you can switch between formal communication, which is about work, and informal communication rapidly and quickly. So these networks form and reform and change minute by minute. So that's kind of interesting, though, because if the communication patterns are what determine whether you have good code, but you can't see it, and you can't measure it, and you can't diagram it, how do you know if it's good or bad? And how do you improve it? So to answer that question, we're going to go back in time to 1968, when clouds of hippies were drifting towards Golden Gate Park. Computer labs looked kind of like this. And in that year, a computer scientist named Melvin Conway wrote a paper called "How Do Committees Invent?", which is now, save you the arithmetic, 44 years old. Still worth reading. In the paper, he outlined Conway's law, which says, any organization that designs a system will inevitably produce a design whose structure is the copy of the organization's communication structure. Now, that's a bit of a mouthful. So I kind of like the way that Eric Raymond restated it. If you have 4 groups working on a compiler, you'll get a 4-pass compiler. And over the years, many people have interpreted Conway's law as one of these kind of funny and not really serious laws, kind of in the same vein as like something like Atwood's law, which is my favorite not too serious law. Anyone know what Atwood's law is? It is that any application that can be written in JavaScript will eventually be written in JavaScript. So a lot of people have thought about Conway's law as sort of the computer science equivalent of people look like their dogs, right? But it's actually pretty serious, actually pretty useful. So one of the most interesting examples from his paper is a project they did, a joint project between the Army and the Navy. And here's what their team structure looked like. They had a set of coordinators, and then they had a team of Army people and a team of Navy people. And the software that they produced looked like this. They had some common functions, and then they had some Army-specific stuff and some Navy-specific stuff. So they built software whose structure was identical to the communication patterns of the teams that created it. So I read that and I thought, well, that's interesting. But I wasn't completely convinced that it was still relevant. A, because people came up with some crazy stuff in the 60s. B, because it's over 40 years old and computing was a really different thing back then. And C, I wasn't entirely sure that something that applied to the military would necessarily apply to the kinds of smaller, sort of less formal organizations that we find ourselves in today. But then, I thought back over the jobs I've had, and I realized that several of them have provided me, unbeknownst to me at the time, perfect object lessons in Conway's Law. So I used to work at a big company once upon a time. Not this one, but they all kind of look the same, right? And the project I was on, the project was actually pretty cool. It was new, it was innovative, the team was amazing. We had a few people who had been around since the beginning of the company and had written large parts of their initial products. And we had people who wrote books about programming. That's kind of cool. I mean, we even had the guy who wrote Free Cell. So how could we possibly fail? And at first things were pretty awesome. My first day I showed up, they gave me a copy of this book. Now, at that time, Code Complete was pretty cutting edge. It's still pretty good. I recommend it if you haven't read it. Don't let this put you off too much. So it started well, but as we got going, we found ourselves really struggling, and it felt kind of like this. We each had a piece of the project to work on. And once the pieces were finished, we started the integration phase, in which we try to get our pieces to talk to each other. And if you'd like to know how the integration phase went, I will refer you to the diagram. It was months of unbudgeted work. And trying to get these interfaces to line up meant we had to kind of make hacky changes to the internals of the components, which we did quickly because we weren't supposed to be spending that time at all. And the whole thing felt terrible. Because I knew I wasn't doing good work, but I didn't understand how we'd gotten to that place. And for years after that experience, after I left the company even, I wondered, how did our code get so bad? We were smart, well-intentioned, knowledgeable developers, but looking at what we output, you really wouldn't have known it. So how did we manage to build modules that completely failed to talk to each other? Now, this was the first time I saw Conway's Law in action, because it turns out that we, meaning the developers, we didn't talk to each other either. So this company believed that every developer should have an office, the door that closed, and they also weren't super big on meetings. So this sounded great to me before I joined, because I was like, I'll have lots of time to focus, it'll be awesome. And I did. I had lots of time to focus. I spent a lot of time being productive, in the flow state, completely focused. Sadly, I was usually focused on the wrong things. Now, I thought they were the right things. Certainly last time I talked to anyone, they were the right things. This culture feels like a bizarro other world to me now, because it's so different from what I do now. But I could go entire days without talking to any of my coworkers, except maybe like awkwardly passing them in the hallway. We had like one or maybe like 2 meetings a week, and those were the only times we ever talked to each other face to face. We wrote a lot of email. Yeah. So in the end, the developers didn't talk to each other, built modules that couldn't talk to each other. We built a copy of our dysfunctional communication structure. And so I was thinking about that, and I'm like, okay, well, but that's a big company. Maybe this is a big company thing, but then I remembered another project that I was on more recently, but before I joined Pivotal, was really a priceless example. This is a small company, and their hiring philosophy for developers was to get really smart people from top schools and let them do whatever they wanted. So they had 8 developers. And their application had a service-oriented architecture consisting of 8 services, written in 8 different languages. Now, clearly, right? Clearly, that's a pathological case. But really, I just wanted to show you that Conway's Law, despite being 44 years old, is in effect today in the organizations that we move around in of all different sizes. So, and it's really obvious at the architectural level. Because basically what Conway's Law is saying is that organizations draw technical boundaries where the team boundaries already exist. But what we're interested in is what happens inside of one of those teams. And it turns out that there was a paper in 2007 from Carnegie Mellon where researchers studied pretty much exactly that. They took Conway's Law as a given and they looked at what happens inside one of those architectural boundaries. Specifically, what they were trying to figure out was the characteristics of a team that led that team to produce good code. And they found a bunch of characteristics that mattered, as you might expect, including technical qualifications of the individuals, which makes sense, right? Got experience with the technology, you'll do better. Another significant factor was previous experience with the code base, which also makes sense, right? If you've seen the code before, you're familiar with its patterns, and you can more reliably find the right place to put something. But the strongest predictor of good code out of a team was good communication amongst the team members. That's really interesting. So here's the first thing I want you to remember. Your team's communication patterns are the best predictor of the quality of the code that you'll produce. Now this is really interesting to me. A, because it's kind of awesome to have science back up my gut instinct, but also because if good communication leads to good code and bad communication leads to bad code, then that sounds a lot like the code reflecting the communication structure, which means that Conway's Law is fractal. And it's most visible at the architecture level, where we see the technical boundaries forming along the team boundaries. But it's also reflected in a more obscured way within a single code base. That's definitely less obvious, right? At the macro level, you can look at the organization and you can just match it up with the software that they produce. But at the micro level, the structure it's reflecting is your informal communication structure, which is largely invisible to us. So you can't start there and look for mirrored structures in the code. But you can go the other direction. You can start with the code and let it tell you things about your communication. Let's look at a really simple example. I went on to a project one time where the view helpers were cartoonishly enormous. There were dozens of files, there were hundreds of methods in some of them, and they were all included into all of the views and all of the controllers, and it was horrendous. So I was just going to dive in and start factoring out the stuff that didn't belong, but I got kind of curious, why would anyone do this? And I poked around a bit, and I discovered that they had an absentee architect. They called him, the developers called him the seagull architect because he'd fly in, crap on everything, and fly off. And at one point, one of the pearls of wisdom that he had dropped was, don't put anything in the lib directory. Now, I kind of appreciate that sentiment, to be honest with you, because for a long time, I thought of the lib directory as sort of every app's junk drawer. And these guys had taken the architect as his word. The lib was nice and tidy, but they'd basically just moved the junk drawer into the view helpers. So I learned two things out of this. First, that I needed to find a way to make the seagull architect less disruptive. And second, that we had a rule of thumb that was generally good, but needed more context and explanation as the developers who were using it gained more experience. So the bad code pointed me towards the communication issues that caused it. So let's look at another more concrete example. Here's a piece of code from a completely different project. And I would characterize this code as slightly smelly, possibly. We have a Rails model here that is including the URL helpers so that it can put its URL into the asJSON method. Now, this is not actually how you include the URL hookers, but it doesn't matter because you shouldn't be doing it anyway. When I came across this code, it really looked like a simple object design problem to me. This code violates the single responsibility principle, right? Which means that it does more than one thing. So models are for persistence-related code. That's their main purpose, but this stuff has nothing to do with persistence. So what that means is there's probably another object trying to get out here, right? Maybe some kind of presenter. And this is a pretty straightforward refactoring. These days, it's mostly uncontroversial. And if we did it, objects would be better factored. And in general, we'd be improving the quality of the code. But before we do the refactoring, it's worth asking, is there anything else that we can learn from this code? So this code came from one of my former teams, and I actually got two really interesting and different things out of it. The first thing I realized was that the presenter pattern hadn't made it far enough out of my head. So in this code base, I had already introduced presenters for other models, but it was a big enough team that not everyone had seen it, and I obviously had not communicated that decision very effectively. The second thing I learned was that some of the developers on my project were ready to hear the more nuanced version of skinny controllers and fat models. Let me explain for a minute what I mean by that. The developers who wrote this code had been programmers for a long time, but were fairly new to Ruby and Rails. And so one of the things we had talked about is don't put model-related code in the controller, right? Skinny controllers, fat models. They had done that, right? Which is awesome, because I totally could have put this code in the controller. And, but they had listened, and they moved it to the model. So what I learned from this is that that instead of giving them the short version of this rule of thumb, I really should be giving them the slightly longer version, which I guess doesn't necessarily roll off the tongue quite as easily. So looking at this software design problem and really digging underneath it showed me two specific problems on my team's communication structure that I didn't know we had, right? Hidden knowledge silo and the new threshold that these developers were ready for. And of course, as a corollary to the last one, I actually discovered that sometimes other developers actually listen to me, which may be the most amazing thing on there. But to do this, we used Conway's law in reverse, right? We let the code smell that we saw shed some light on our communication structure, which otherwise is mostly invisible to us. And what we got back from that is really valuable, right? If I tell everyone about presenters, and I revisit where you're supposed to put model logic, then I address the root of those problems. Whereas if I had just refactored the code, I really would have just fixed the symptoms. And over time, fixing the code and fixing the communication difficulties that the code helps you identify pays way more dividends than just fixing the code. So in short, this is the second thing I want you to remember. Every piece of bad code is trying to tell you something. When you figure out what it is, fix that. Because fixing those communication problems increases the quality of the code that all of you write on the team. So finally, I'd like to put the last piece of this puzzle together and talk about how you fix communication problems. Now, I've been at Pivotal Labs for almost 3 years, which is a really long time. And if you're not familiar with our process, we do all pair programming. And what that means is that we actually sit with somebody all day, and we talk about the code that we're writing together. It's actually really fun. And the interesting thing about it is it turns writing code into an act of communication. So for the last 3 years, minus vacations and holidays, I've been pairing for 8 hours a day, 5 days a week. And in that time, I have kind of become the carpenter who has any tool you want as long as it's a hammer. And of course, my hammer is pair programming, and a lot of these communication problems look like nails. Now, I did say that I wasn't going to rant. But why is it? Why is it that some developers are so rabidly opposed to pair programming? I mean, leaving aside the question of whether or not it's effective, right? Since there have been loads of studies on that, why is it that some developers just don't want to do it? Now, what I think is that they don't want to do it because they don't know how to talk to people and they think it'll be awkward. And the reason I think that is because that's what I thought before I started doing it. But here's the thing. You are a human being. And learning how to talk to other human beings is a skill that you should learn. Because easily talking to people is not a talent that you either have or don't have. It's a skill. It's a skill that you can learn and get better at. And I think you'll find that spending time talking to an engineer while you're pairing is actually significantly easier than spending that time talking to a normal person. But the practice still counts. So about 3 months after I started at Pivotal, I went to an alumni event from my university where there were normal people there. And I was kind of shocked to discover that I could make small talk with them, which was something I'd never really been able to do before. And not only that, I was actually pretty good at it, you know? I asked them questions about themselves and kept the conversation going, and it was pretty cool. And I went home that night, and I sat down and I was like, what just happened? Am I turning into an extrovert? Like, what's going on? Now, but that was a side benefit for me, but it was one of those things that I never expected to come out of it. But pairing is difficult, right? It's super hard. I won't tell you it's not difficult. It is exhausting at first to spend all of your time talking. The first few months I was at Pivotal, I was so exhausted that I actually really don't have clear memories of that time. And the only other time in my life that I've been like that is when I had a baby. So it's hard, but it's worth doing. No matter how awkward you are now, which I know none of you are, you can learn to talk to people. Because that skill, that ability to connect with people is what makes us human. And that's all I have to say about that. Okay, back on script. Fixing problems. So the first thing I'm going to tell you, the non-rant version of that, is that if you're serious about wanting to increase communication among your team, pair programming, even if you're doing it ad hoc or part-time or temporarily, is actually a really efficient way to get all of you to talk to each other more. And there are, of course, other ways to get people talking. So let's go through them. The first one is create opportunities for informal communication. So science tells us that informal and accidental communication are critical parts of your team structure. People need to have opportunities to have conversations with people that aren't totally about code. So there are lots of ways to create this space. And one of the most effective is to sit together in the same place. So you overhear each other talking about stuff. You can contribute if there's something you know about. And this works for distributed teams, campfire, whatever. And another way is to create a space in your office for people to relax, right? Sometimes it's easy as bringing a couch into the office or like buying a fancy coffee machine that people have to like show each other how to use. So look for ways to bring up the level of ambient communication in your workplace. Second, use high bandwidth communication when you need to talk to someone. Face-to-face communication is still the highest bandwidth communication that we have because you get lots of meta information along with the actual information, right? Body language, facial expressions, which I love in this picture because they're so goofy, the voice intonation and all that stuff, right? So if face-to-face isn't an option, then in descending order of usefulness, of course, there's video chat of some kind like FaceTime or Skype or Google Hangouts, and there's phone, instant messenger, tracker comments, email, carrier pigeon. I don't really recommend those last three if you can avoid them. And finally, keep in mind that communicating easily with people is not a talent that you have or don't have. It's worth saying twice. It's a skill. It's a skill you can learn and practice and get better at. So one thing I will say about these is that you will have the most impact using them if you are a team lead or a manager, but they're still effective if you're not. I don't know how many of you ever read Dear Abby, but as a kid, we had these things called newspapers that showed up at our house periodically. And Dear Abby was the one thing that I always read every day, even after I decided that the comic pages was a waste of space. And Dear Abby is an advice column, and people would write in asking for advice, usually about their marriage. And Abby's advice to those folks was remarkably consistent. It was, go to couples counseling. And if your partner won't go with you, go by yourself. Now, it sounds really weird, right, to go to couples counseling alone. But what Abby knew was that learning communication techniques and taking them back home often improved the relationship, even though only one person was actually going to the counseling. So these things are very similar to that. You can do them yourself, and both you and the rest of your team benefit. So the last thing I want you to remember is hack your team. You have more power than you realize. The communication patterns within a team can be drastically affected by one person. So go forth and do these things. And if you do, I think you'll find you spend more of your time writing good code. And I really hope that that makes you as happy as it makes me. Thank you very much.